In this chapter, we will be looking at sinusoidal functions. In this particular chapter, we will be looking at modeling using sinusoidal functions. To begin, let's spend some time looking at the equation y equals a sine of b x minus c plus d.
All right, so in this lesson, we're going to take a quick look at relating the graph of a sinusoidal function to its equation. And so, just relating the pieces here, normally when we write out a sinusoidal equation, it'll have this form right here. It'll be y equals a times the sine of b times x minus c, and we close the brackets there for the sine, and we add d at the end. And a, okay, that first coefficient there is going to be the amplitude. We'll determine the amplitude. Now we'll zoom in a little bit on this here. Okay, that amplitude is going to be determined by taking the maximum value of the function, we'll subtract the minimum value and divide by 2, because the amplitude is half the distance from the bottom of the graph to the top of the graph. Okay, so a sinusoidal graph kind of looks like this. Remember that amplitude, we're going to cut it in half, and the amplitude will be that distance, or if you want to think of it, that distance. Now, the b value here is related to our period. Okay, remember the period is the amount of horizontal space it takes to get through a full part of the curvature there that gets repeated. Okay, the period. The period is related to the b value, but it's not directly. It's not the same thing here. It's going to be either 2 pi divided by b, that's the period, that'll be that length there, if we're talking about radians, or it'll be 360 divided by b if we're in degrees, okay? A better way to think about b is actually more like the frequency, okay? b tells you how many periods you get in that first section there, that 2 pi radians. What would normally be a period on the graph here, b turns out being the frequency, how many of those you get in that space of time, if you will, or just that horizontal space on the graph here. Now, c is going to be responsible for moving the graph left and right, but that causes some difficulty with a bit of the math there, and in this particular course, we're not really all that concerned about the c value. We will notice it pop up here and there, but we're not overly concerned about that value right now. We are, however, concerned about the d value at the end here, this value that we add after all of this has occurred. Okay, the d value is what we might call the median. It's the middle of the graph. It's this line right here where this line occurs. Okay, because it doesn't always have to be the x-axis, this line right here. It can be elsewhere. And we get that by taking the maximum value the function gets to, we add the minimum, and then divide that by 2. Really, it's an average of the maximum and minimum values. And all that together, it gives us these pieces, the parameters of that sinusoidal function. So now what we're going to do is we're going to look at some word problems and basically apply these pieces to different contexts.
The graph shows the height h in meters above the ground over time t in seconds. It takes a person on a chair in a Ferris wheel 72 seconds to complete 3 revolutions. The minimum height of the Ferris wheel is at 3 meters and the maximum height is at 33 meters.
Alright, so the question is obviously about a Ferris wheel, and we're given some information about how it behaves here. Let's take a look at the questions. First of all, here's the graph, roughly, of the motion. And here we go. At what height does a person get on the Ferris wheel? Okay, let's just take a quick look here. Now, just think about the way a Ferris wheel works. Okay, where do you normally get on? Well, you get on at the bottom. They drop the wheel down, you get on the very bottom. Let's take a quick look at what it said here. That last sentence gives us the information. The minimum height of the Ferris wheel is 3 meters. So at what height does a person get on the Ferris wheel? Well, we get on at 3 meters. That's actually still relatively high. You got to obviously walk up to that, but yeah, that's that low point on the graph there. What is the radius of the Ferris wheel? Okay, now that's an interesting question. The radius of the Ferris wheel. Now that is the distance. Think about what a radius is. There's your wheel. Okay, the radius is the distance from the center out to the side. So there's my radius. But that could also be drawn either here or here. So from the center to the bottom or the center to the top. Now let's think about where have we talked about that in the context of a sinusoidal graph? And the answer is Well, that's the amplitude of the motion. The amplitude runs from the center to the top or the center to the bottom. So this question right here is really asking for the amplitude of the motion. And we get amplitude by taking the max minus the min over 2. Okay, now we've read here the minimum value that we get to here is 3 meters, and if we keep reading, the maximum height is 33. Okay, well that's going to be 33 minus 3 over 2. 33 minus 3 is 30, divided by 2 is 15. So the amplitude of this wheel, or sorry, the radius of this wheel is 15 because the amplitude of the motion is 15. If we were to go up to our graph right here and just draw a line straight through at 15, and in fact let's maybe just kind of pull out a ruler, let's just quickly do that. That is going to be the center of the motion. I will go 15 above that and then 15 below that to get to the peaks and the troughs there. How long does it take to make one revolution around the Ferris wheel? Well, we're not given that information specifically, but we are told generally what's going on here. We know that we get 3 complete rotations of the wheel, okay, in 72 seconds. 72 seconds. So what we got to do here is we got to take that 72 seconds and divide that by the 3 specific rotations, and this will give us the amount of time it takes for just one rotation. Okay, and it turns out 72 divided by 3 is going to be 24. So each one of those rotations is going to be 24 seconds. So that ends up being the period of the graph. Now, knowing that, we can actually come up with the b value for this graph here. B is going to be 2 pi divided by the period. Now, in a previous, up above here, you saw that the period is 2 pi over b. And it's just a nice little quirk of the algebra here that you can swap those two. So b is equal to 2 pi over the period. And we're always, when we're talking about word problems here, we're always in radians. Okay, we're always doing radians here. This ends up being 2 pi over 24. And I'm not going to worry about the pi in there. I don't mind having the pi, but I'll simplify 2 over 24, and this will become pi over 12. So that's the value of b in this particular problem. And I know that the question wasn't specifically asking for it, but when it asks for the period, that's not an unnatural thing to do, is to find the value of b. The last question here that we get for this particular problem, at least I think it's the last question, yep. Estimate a person's height above the ground at 52 seconds into the ride. Now we're just estimating this, but I'm going to show you what we can do here to get something better than an estimation. But we'll start with just the estimation here. 52 seconds. Let's go to our graph here. Let's take a look. Well, here's where 52 is. 52 seconds is right there. So I'm just going to take my ruler here and just slide it along until I get to my 52 mark, go up. And when I hit that, now granted, I'm not being really careful with this. I'm not, making sure that I'm 90 degrees and parallel and whatnot, but that's roughly hitting that graph at around 15, okay? That's close to the center of that motion here. So I'm saying about 15 seconds. It's at 52 seconds. I'm saying that's at 15 meters, roughly. Okay, just a quick estimate there. Now, I can do a little bit better than that because I already know that my amplitude is going to be 15. I know that my b value is going to be pi over 12, okay? Because I just figured that out here. D is going to be my maximum plus my minimum divided by 2. I saw that above here, so that's actually going to get me, That's going to get me 33 plus 3 over 2. Well, 33 plus 3 is 36, divided by 2 is 18. So I know A, B, and D. So I'm going to write my equation as y equals 15 sine of bracket pi divided by 12 times x. Now I don't know what C is, so I'm just going to kind of leave that blank right now, and I'm going to put plus 18 here. I don't know what I should put in there, but I'm going to play with this first. Now I'm going to go to my calculator. Okay, I'm going to make sure that I'm in radian mode to start off with, and I am. And now I'm going to enter in those pieces here. So 15 sine of pi divided by 12 times x. Now I'm not quite sure if I'm going to put a c in there yet. We'll see. Plus 15. Or sorry, plus 18. My mistake. 18 was the middle. Okay? Plus 18. Now, my window settings, I should start at 0, and I saw that my graph went to 72, or roughly 72. My scale, I don't know, if it's going up to 72, let's go up by 10s. That's probably good enough here. My y-min, well, it doesn't have to be less than 0. The graph's not going underground. And my max should be larger than 33, so let's just say 36. And then we can have the y-scale go up by 3s. That doesn't really matter. Let's see what the graph looks like. Okay, so you can see here we do have roughly, we got 3 periods here, but notice that it's not starting in the same spot as the original graph here. My graph is starting at the center and going up. Well, I got to move that over. That's about putting in a C value. And I don't quite know how much to do this by, so I'm going to come to that little parentheses there, and I'm going to insert something in there. Let me add, I don't know, let's add 10 to it. Let's see what happens when I add 10. It seems to have moved the graph, but now I'm starting here and dropping down. I don't really want that. You know what? Maybe making a big move like that wasn't as useful. Maybe we should be doing this in smaller chunks. So let's go back and let's delete this. Take a look at the original graph. And then we'll just use little increments here. Okay, so let's maybe go back to y equals. I know what that graph looks like. It starts at that center. It starts at the middle of the graph and goes up. And so let's insert here, for example, let's add 2 to it. We'll go up little increments of 2. Well, now that's interesting. Now I seem to be starting higher. And it goes up higher. So it looks like this graph has moved over a bit. So let's do this again. Y equals, let's make this 4. We'll just go up by 2s here. See what the graph looks like. Ooh, now I'm starting even higher. So it looks like the graph, every time I added to that, it seems to be moving to the left. Okay, I'm going to go back to y equals. Let's add 6 there. Oh, now look at that. Now instead of starting at the center, I'm starting way there. I'm starting right up at the top. I used to start at the middle and go up to the top here, and when I moved it 6 units over, I got to there. I got to the very top. Well, now I'm kind of curious. If I add another 6 to that, so let's make this 12 instead. I'm guessing that I'm then going to start at the middle and go down. And there it is. Starts at the middle and goes down. So every time I move this thing over 6 units, I seem to jump from the middle to the top to the middle, and I'm hoping now to the bottom. So now if I put another 6 onto this and I make that 18, and there it is. I'm starting at the bottom. Now you don't really have to follow on what I'm doing here. This isn't required stuff here, but it's just interesting to note that that C value in that graph moves the graph left and right. And I've been able to just by playing with this a little bit, figure out that every time I add 6 to it, I move that starting point, the graph moves over a quarter of the period. And now what I can do, because this is now looking like the graph on the page there, I can now go into my trace menu, my second trace, to get to the calc menu, and it's wondering, okay, how high up it is at 52 seconds. So now I enter in 52 into x. Oh, and the answer that I get here is actually 10.5. Okay, it's actually 10.5 meters. Because I've got a far better model now, because my calculator model looks exactly like the one that they give you right here. So I actually have a lot more faith in that than I do the kind of wonky lines that I've drawn. Anyway, there's one way to approach a problem like this.
The minimum depth of water in a harbor can be approximated by the function d of t is equal to 5 cosine of 0.5t plus 12, where t is between 0 and 24.
Okay, so we have this model for the depth of the water in a harbor, okay? 5 cosine of 0.5 t plus 12, where t is between 0 and 24. So that strikes me as the time of the day, the hours, okay? So that's what we can assume t is. And we want to determine the maximum and minimum values. Okay, well, we've talked about this before. We know what the pieces represent here. It doesn't really matter that this is cosine. The graph is still going to be called what we call sinusoidal. It's going to have that nice little wave to it. We've already established that this number at the end here is our median. Okay? That's the middle of the graph. Okay? The graph goes up and down, up and down, up and down, but the middle of that graph is going to be represented by this number right here, so 12. And then this number right here is our amplitude. And remember what that, oh, sorry, not app. No idea why I wrote that. Amplitude. And remember that amplitude is the distance from the center to either the top or the bottom. So if I want to know what the maximum is, I look at the median, the middle, and how far up I go. So my max, in this case, is going to be 12 plus 5. Okay, plus that number right here. Now, if this was a negative number up front here, it really wouldn't have made much of a difference. I would still be adding 5. Even if it said negative 5 here, I'd still add 5. When there's a negative in front, all that really does is graphically determine which direction the graph starts moving. It doesn't really alter the fact that the amplitude is the numeric value, 5 here. So the amplitude here is going to be 17. Sorry, the maximum here is going to be 17. The minimum will be the middle value, the median, but this time we're going to subtract that amplitude from it. And so in this case, 12 minus 5 is going to be 7. So the maximum value is 17, the minimum value is 7. Now that leads directly into this next question, determine the range. Okay, well, the range is going to be illustrated by, or identified by these values right here, the maximum and the minimum. So it's going to be 7. All of the values of the y-coordinate here are going to be greater than or equal to 7, but at the same time less than or equal to 17. So there's our range. The period of the function, well, the period is related to the b value. And remember, when we're talking about word problems, we want to be in radians. Okay, so this is going to be 2 pi divided by the b value. Now we got to go back to the function to figure out what the b value is. Okay, so 5 cosine. B shows up within the function, and it's the number that's multiplied by the variable here, so 0.5 times t. Okay, so this is going to be, the period is going to be 2 pi divided by 0.5. Now, 0.5 is like 1/2, and when you take 2 pi and divide it by 1/2, you're going to get, that's like multiplying by the reciprocal, so you would take 2 pi, multiply by the reciprocal of 1/2, which is just going to be 2 over 1, and your result is 4 pi. Now, that's not a very useful number though, okay, because we're talking about water in a harbor. We're talking about how it fluctuates up and down here. So if someone says, how long does it take the water to go from like low tide all the way around to low tide again, and you answered 4 pi, well, what the heck is that? What does that mean? So what we want to do here is we want to convert 4 pi into a number that actually makes more sense to us. And so 4 times pi numerically is roughly 12.566, and you can see how that goes on there. Okay, well, this number means something more to me. This is going to be 12 hours and 0.566 blah 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 of an hour. So I know that this is going to take, okay, this is going to take 12 hours. Now I want to figure out how many minutes it's going to take. Now don't say 56 minutes or 57 minutes here, depending on how you want to round that. Don't say that, because this is a decimal, this is a fraction of an hour. Time isn't metric. Okay? If there were 100 minutes in an hour, then that would make sense that would be 56 minutes, but there aren't. So what I'm going to do is I'm going to take that 12 off of that number to start off with, just so that I'm looking at the decimal there. And now I want to figure out what fraction of an hour that is. So there's my decimal value. I'm going to multiply that by the number of minutes in an hour, 60. So this represents 0.5663 3 blah 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 of an hour, so multiply it out, and I'm getting roughly 34 minutes. Okay, in this case here I will round that, so 12 hours 34 minutes approximately. Now, what is the depth of the water at 2 o'clock? That's this last question here. What is the depth of the water at 2 o'clock or 2 a.m.? Okay. Well, time is inside the equation here, so we're going to just plug that in. So I'm just going to plug this into the equation. I'll plug it 2 in for time here. So this is going to be 5. Now, first of all, I have to make sure I'm in radian mode, and I am. So I'll quit. So 5 times the cosine of 0.5 times 2, there's 2 a.m. in the morning. Now, if it was 2 in the afternoon, okay, because of the way we have to measure time here, I'd have to put 14 there. Okay, I have to use the 24-hour clock. And then the end of the equation tells me to add 12. And so I'll get that this is roughly 14.7 meters. Okay, there you go.
The mean daily temperature of Comacock Beach in the Yukon are represented by the formula T is equal to 17.11 times the sine of 0.52 m minus 2.83 minus 5.38, where T is the temperature in degrees Celsius and m is the number of the month in the year.
Okay, so we've got some information about how temperature behaves in this place in the Yukon here. So the first question we get asked here is, from the equation, calculate the maximum and minimum temperatures. Well, this is very similar to the previous question. First of all, what we're going to identify is the pieces that we have in the equation here. Okay, I know that my amplitude is going to be 17.11. I know that my B value, now B value isn't the period, but it's related to the period, but my B value is 0.52. That value of C in there, again, is responsible for left and right motion, but we're not really all that worried about that. So we're not going to worry about, copying that down right now. But the negative 5.38, that's my median value, if you will. So negative 5.38. The maximum and minimum values can be found by combining these two. This is the middle, and this is how high up it goes from the middle and how low it goes from the middle. So to start off with, my maximum is going to be equal to negative 5.38 plus 17.11 degrees. And so the maximum that it gets to is this 11.73. Okay, I'm assuming that's degrees Celsius. The minimum that we're going to get to will be negative 5.38. Now we're going to drop below that, so we're going to subtract 17.11. The answer is negative 22.49 degrees Celsius. So those are our maximum and minimum values. The next question says, calculate the period and explain its significance in the context of the question. Sorry. Well, period is related to the B value. Okay, and we saw earlier, that period is equal to 2 pi over the B value. Now we've got to be in radians for these word problems. So this is going to end up being 2 pi divided by that value 0.52. Now let's go to our calculator here. Okay, 2 pi divided by 0.52. And the answer is 12.1, but we're roughly 12 here though, okay? So approximately 12. Now, that makes sense here because there are 12 months in a year. Okay? There are 12 months in a year. So we do assume if time is being measured here, I jumped way too far ahead here. If time is being measured in terms of months, then we do assume that the period of this graph here is going to be 12 months. 12 months in a year. Okay? Because from January to January, that's when the whole process starts over again. All right. Now, give the equation of the midline. Well, we've already got that. Okay, the equation of the midline is going to be y equals, well, that's the D value. And the D value in this case is negative 5.38. So that's an easy one. It's kind of given to you right there. The next one here says to give the amplitude. Well, that's easy because the amplitude is that A value up front. We've already identified it at 17.11. Okay. Now, the next question here says determine the temperature during March. Okay, well, to do that, this is an evaluating sort of question here. I'm going to plug in a value and let the equation spit out a number here. And in this case, the number I'm going to plug in is going to be 3. Okay? Because March is the 3rd month. So we're just going to plug that into the calculator and see what we get. So again, we got to make sure I'm in radian mode, okay, because for these applications. And so now we got here 0.11 sine 0.52 times 3 minus 2.83 minus 5.38. Enter. And it looks like that temperature is negative 21.7. Approximately negative 21.7 degrees Celsius.
A seat's position on a Ferris wheel can be modeled by the function y is equal to 18 cosine of 2.8 x plus 1.2 plus 21, where y represents the height in feet and x represents the time in minutes.
All right, notice in this question we're back to Ferris wheels. That's a really common question to go to. It's an easy one to make questions from. The first question says determine the radius of the wheel and what does it represent. And actually I think it probably should say here determine the amplitude of the motion and ask what it represents, because the truth is it represents the radius. Okay, amplitude and radius are going to be the same thing. And so in this case right here, what we're doing is we're looking for that initial number here in front of the trig function. So in this case the coefficient is 18. So the amplitude here is going to be 18 feet, which means the radius of the wheel is 18 feet. Because the amplitude is the distance from the center to the top or the center to the bottom, and you know what, that's exactly what the radius of a wheel would be. Next question says determine the amount of time it takes to make one revolution. Well, that's what a period is. And so the period is going to be 2 pi, because we're in radians, divided by b. In this case, the b value, which would be the coefficient of the x, okay, the independent variable, that coefficient is 2.8. So we'll come down here, this will become 2 pi divided by 2.8. So now come to our calculator, 2 pi divided by 2.8. And we get 2.2, roughly. Okay, so approximately 2.2, what is that, minutes. What's the maximum height? Well, okay, the maximum height, we get that, remember when we look at the graph, the equation here, this number here is the median. It represents the middle of the graph. Okay, so when you were to write this out, kind of draw the graph with this little wave here, the middle of that motion will be at 21. The amplitude is 18. So what we're going to do here is take that middle of the graph here and add the amplitude to it. So the maximum is going to be 21, the middle, plus the amplitude at 18, and together that's going to be 39. Oops, sorry, I was going to write meters, but remember this question is in feet. Okay, so there you go.
A Ferris wheel has a radius of 8 meters and its center is 10 meters above the ground. A rider gets on a chair of the Ferris wheel at its lowest point and completes one full revolution in 48 seconds.
All right, so we're given, again, some information about a Ferris wheel. Then we're asked here to state the amplitude, period, and the equation of the midline. Okay, let's go back and grab some information here. So we know that the radius is 8. That is the amplitude. Okay, so we've done enough of those problems to know that there's a connection between the amplitude and the radius. Its center is 10 meters above the ground. Well, that's beautiful because that's our D value. Okay? And in fact, that becomes our midline. So the equation of the midline here is going to be y equals 10. That's the middle of that graph there. And what do we got here? A rider gets on the chair at the lowest point of the graph, okay, and completes one full revolution in 48 seconds. So it goes all the way around in 48 seconds. That's the period. So the period is 48 seconds here. Now, almost every time we get asked about the period, there's going to be a related question that follows that deals with the b value. So now remember, b is going to be 2 pi divided by the period. Because with that formula, remember, you can switch b and period whenever you want there. So we're looking for the b. The period was 48 seconds, so it's going to be 2 pi over 48. And that would simplify down to pi over 24. And I don't really care to go any further than that. Pi over 24 is fine. So the period is 48 seconds. This is what the b value is. Now let's take a look at the next question here. Determine the function in the form, okay, and they give us the form of the function, where h is the height of the rider above the ground. Whoops, sorry. And t represents the time after the ride has started that could be used to model height. Okay, so we're just coming up with the equation. Well, that's beautiful because we've already got everything we need. H then is going to equal A, amplitude, I know that that's 8, sine of B, I just figured that out, that's going to be pi over 24 times t minus 1.57 plus D, and we figured that out, that was going to be equal to 10. And there we go. That's the equation that we were looking for. Okay? It was just written out for us, and we'd already figured out all the pieces. All we had to remember was where to put those pieces in the equation.
Enter the following data into a graphing calculator in the Stat, Edit, and Enter mode of the calculator.
All right, now with this question right here, we approach this a little bit differently. We're not given the equation, we're given data to enter, and we're going to let the calculator come up with the equation here. So here's the data, and here's our calculator here. First of all, I'm going to make sure I'm in radian mode, and I am. Now, to enter the data in, what I'm going to do here is, this is really a statistical operation, so I'm going to press Stat, which is going to open up a menu that looks like this. Now what I'm going to do is press Enter on the Edit menu to get into my list. Here's my statistical list here. Now typically, and we can change this if we want, but the calculator by default would recognize this as my X list and then L2 as my Y list here. So I'll enter in the X coordinates that I see here. So 0, 6, enter, 18, enter, 25, enter, 33, enter, 41, enter. Now I've got 1, 2, 3, 4, 5, 6, and I've got 6 data points in there. Good. Now we move over to the second list here, and I'll enter 0.5, 29.5, 18.6, negative 23.7, negative 39.2, and then positive 0.7. Okay, so there's the data that we need in lists 1 and list 2. Now, the very first question that we're being asked to do here is to perform and write the regression equation and round all answers to the nearest hundredth. Okay, so here's our equation, our data. We're going to quit to get out of there to start off with. To do the regression, we're going to press Stat again, because we're going to try to access the information in that list here. And this time we're going to go over to the Calculate menu. And we're going to do a regression here. And this is all of our, well, okay, the first two ones here aren't regressions, but everything from this point on is a regression. We're going to go down. We've got the two up here. These are linears. This is a quadratic, the cubic. Here's a quartic regression. Here's another linear regression, written a little bit differently. That's logarithmic, exponential, power, logistic. And then way down here, we've got a sine regression, the sinusoidal regression. Now, when my calculator does this, it opens up this menu right away here. What you want to make sure is that your X list is list 1, your Y list is list 2. We're just going to run down here and let the calculator assume everything else is correct the way it's supposed to be. So calculate. Okay. And here we go. So our regression, okay, is our A value. Now notice the calculator gives us the equation and then it tells us what the pieces are here. So the regression equation, based on what we got written here, I'm going to write this out, is going to be y is equal to, now to the nearest hundredth, 40.94 sine, okay, now look at the way it's written here, so it's going to be 0.15, so 0.15x, in this case, minus 0.05, 0.05, and then the d value here is 0.86, 0.86. And so there's our regression equation, the way the calculator's given it to me here. Now I can go on and answer the rest of the questions based on this equation here. So determine the maximum and minimum values of the data. Okay, well, notice that what I've got here, and actually I'm pretty lazy. I like using the calculator to do stuff like this. So notice that the A value here is already positive. And that's important here because when I do the calculations for maximum minimum, I was going to make that positive anyway. But now watch what happens here. My maximum value is going to be the D value plus the amplitude. Remember the middle plus the amplitude. And then the minimum value will be the middle value, D, minus the amplitude. I can accomplish that by pressing vars. Vars gets me into this menu right here. It looks like this. And what I'm interested in is the statistics one. I go way down here. I'm going to grab statistics and EQ for equation. And then what I'm going to do is I'm going to go down here and grab the D. There's my D. And I'm going to add to that. I'm going to go back into vars, down to statistics, EQA. And when I press enter, what it does, the calculator puts those two together. Now it puts puts the two together without rounding them first. So my answer here is as close as I can get here. So that's going to be D plus A is my max. Sorry, I should write that as just D plus A. And the answer in this case to the nearest hundredth was 41.36. Okay. Now what I'll do is I'll press second enter, and what that does is it pulls that last thing that I entered in there back up, and I'll put a subtraction in there instead of an addition. And then we get that our minimum value, which is D minus A, will be negative 39.63. So our minimum here is going to be D minus A, and we got that was negative 39.63. Okay, good. Now, let's give the amplitude and the equation of the median. Okay, well the amplitude, remember, was the A value, and we saw that this was 40.94. And the equation of the median, well the equation of the median is always y equals d, and in this case the d value is 0.86. And so I'm just pulling that information out exactly the same way I have done it in the past there, so there's nothing really new there. Give the domain and the range. Okay, well our domain is going to be element of the reals. We're assuming that this goes on forever and that all we're looking at here with this data here is just a section of the data, a portion of the data. The range is going to fluctuate from the minimum to the maximum. We've already identified that. So this is going to be negative 39.63. That will be less than or equal to y, which will be less than or equal to 41.36. That's our minimum or our maximum that we found in the second question there. Okay. Now based on the equation, what's the period? Okay, well our period, we have a little equation for the period that's going to be 2 pi divided by the b value. Now, we know the b value is 0.15, but the b value is already stored in the calculator, just like those other pieces there. So I'm going to enter here, and I'll do it in brackets here, 2 pi, and I'm going to divide that by the actual b value. So again, I'm going to press vars. Sorry, I meant to say vars. Vars to go down and find the statistics variables. We'll go over to EQ, and the one I'm looking for is b, right there. So 2 pi divided by b. I mean, it's exactly the equation that I'm trying to use here. Press enter, and we get that the period here to the nearest hundredth was 40.83. Okay, and actually that bears itself in the data as well. I mean, starting at 0, by the time we get to 41, we've gone from 0.5, we've gone up, we've gone way down, and then we're back up again to the middle here, and that seems about right. So that's good.
The table below represents the time in minutes versus the height in meters of a Ferris wheel. The diameter of the wheel is 76 meters.
All right, so this next question here, again, we're talking about a Ferris wheel, and again, as with the previous question, we've been given data to enter, not an equation. So we're going to have to build the equation from this. So once again, we're going to have to put the data in here. Now, I press stat, and I'm going to go into edit here to put the data in. Now, the data that I'm seeing right here is left over from the previous question that I just worked on here. Now, I want to show you how to get rid of the data here. You could overwrite it if you want, but you can also go up and press clear. Now, notice what happens if you press clear. It gives you a moment here. It actually clears out all the data there, and it's actually waiting for you to press enter to confirm that that's what you actually want. If you press enter right now, it clears all that data. Now, if you go up and you're not being careful with this, if you inadvertently press delete, and that's a fair thing to do, But if you press delete, watch what happens to list 1. Okay, list 1 actually goes away. It's gone. Okay? So, but I wanted list 1. I wanted to put my data in list 1. So I need to put that list 1 back in there. So the opposite of delete is insert. It's just above the delete button there. So I'll press second, delete. I'll make sure I'm on list 1. List 2 is highlighted, I should say, that list 2 is highlighted. So press second, delete. And what that does is it pushes a column in there and gives me an opportunity to name it. And I want to name it list 1. And I get list 1 or L1 by pressing second, then number 1. Okay? So second number 1, it's going to put list 1 in there. And when I do that, notice it didn't actually delete that list at all. It just stopped showing it to me. So all that data was still in there. So what I want to do is I want to clear it. So I've highlighted list 1. I'm going to clear and then enter. And now I can enter the data that I've got in this equation here. So list 1 is going to be 0, 2.25, 4.5, 6.75, and 9. And then the height, or the y data here, is going to be 8, 46, 84, 46, and 8. Okay, good. There we go. There's our data. So now the first question asks me to perform a sinusoidal regression and then round the parameters each to the nearest hundredth. Okay, so here we go. So I'm going to quit out of there. And then to perform the regression, remember we press stat, because this is a statistical operation. We're going to move over to the calculation menu, and then we're going to go down and look for that sinusoidal regression. And it's down here at C. Now my calculator's already set up. It knows that I want to look in list 1 and list 2. So I'm just going to let it figure the rest of that out here. And there we go. So now the pieces are going to be 38. Okay, well if I round that to the nearest hundredth, 0.70. Negative 1.57, and then 46. So here we go. So y, or in this case our height, okay, height is going to equal 38 multiplied by the sine of 0.70, remember that's going to be rounded, t, minus 1.57, and then plus 46. Good, so there's our equation. Now that we've got the equation, actually it's fairly easy for us to answer the rest of the questions here, because this has got all the information in it that we need. So now determine the period of the graph and describe what it represents in this scenario. Okay, well the period, remember, we have a little formula for periods, 2 pi over b, assuming that we're in radian mode. Now, b here in the equation is 0.7, but when the calculator figured it out, it did a little bit more precisely. So I'm going to stick with what the calculator's got. Remember how I do that? I will enter 2 pi, and I'm going to divide that by b. Now remember, the calculator has already stored b in a variable here, so we're going to press vars to access that variable. It's down here as a statistical variable. Press enter. And it's an equation here, so, and then there's b right there. So 2 pi over b. Oh, and we get a beautiful number. It's just 9. Now, that is the period of this motion here. And when you're thinking about a Ferris wheel, what the period is, it's the amount of time it takes to go around once. So it takes 9 minutes to make 1 revolution. Okay? That's what the period means in this context. All right, good. Now, what is the relationship between the amplitude and the diameter? Well, I don't really even need the equation to tell you this right here. Remember what amplitude is. Amplitude is the distance from the center of the motion to the top, or the center of the motion to the bottom. Now, if you think of a wheel, center to the bottom, center to the top, that's the radius. So therefore, the diameter, okay, is going to be equal to twice the amplitude. Just like it would be twice the radius, because the amplitude really is the radius. Okay? Now, let's take a quick look here. How high above the ground did the people board the Ferris wheel in this scenario? Okay, well, what we're going to do here, actually, we're going to take a quick look at the equation. Or actually, sorry, I shouldn't even say, I don't even need to really do that. How high did they board the ground? Well, we're assuming that when the people get on the Ferris wheel at the minimum height, Okay, so that's the assumption here. They get on at the minimum height. And so what that's going to be is our minimum is going to be the d value minus the a value. Now, I could go into my calculator and pull out those variables here, but the truth is 46 minus 38, the answer is 8 meters. And I also get that confirmed from the chart here. When time is 0, the height is 8. I mean, I'm assuming that that's the beginning of the ride, and so we're getting on at the lowest possible mark there. So 8 meters is what we're getting there. Now, how far above the ground would a person be after 3 minutes? Okay, well, that's an interesting question. And so let's do this. Now that they're asking questions kind of about a specific point in the motion, let's graph it. So, to graph it, I'm going to press y equals. Now I've got some old data in there, so I'm going to delete that. I want the calculator to put the regression equation here. Now, I have the regression equation that I've written out, and I've rounded everything. I'd rather the calculator gave it to me to the most precision it can give me. Well, the calculator has stored that all in here, and I've already kind of given you an indication of how you grab that information. So once again, now that we're in y equals, I want to press vars, because the calculator stores this stuff all in variables. Again, we're going to go down to statistics, and over to EQ, and when I do that, the very first option that I get is regression equation. And when I press enter, it takes that regression equation that it just found and puts it in there for me. Okay, now what I'm missing is the window settings. So I'm going to go to my window settings. I think it makes sense for me to start at 0. Okay, and we've already determined that a period is 9 minutes here. So I'm going to let it go to 9. Okay, my minimum, well, it makes sense to make the y minimum here 0. Yeah, because I mean the Ferris wheel doesn't go underground, it stays above ground. Now let's just think about this. What would the maximum be? Well, one of the beautiful things about the calculator is what we can do right here. I know that the middle of the graph is at 46 and that it goes up 38. Now if I press enter right now, it's going to add those two together and it's going to give that to me here. But I want to give myself just a little bit of a barrier here. We got on at 8 meters above, so I'm actually going to add an additional 8 to that. When I press enter, it gives me 92. So that's going to be the maximum height here. I'm okay with my, well, actually, you know what? I'm going to make my scale equal to, let's make that 10, just for convenience sake here. Now when I press graph, I'm going to see the motion. So I've got a little bit of room at the bottom, I've got a little bit of room at the top, and there's one complete revolution around the Ferris wheel here. Now the question is, how far above the ground would the person be after 3 minutes? So let's go into our trace menu, or sorry, we're going to press second trace to get into the calc menu, I should say. So calc. I know what the x coordinate is that I'm interested in, so I'll press value, and x is going to equal 3 for 3 minutes. Okay, and I can read that right off the graph. It turns out that's at 65 meters here. That's actually terrifyingly high. Yep, that's a ways up there. Now, at what point is a person 15 meters above the ground in that complete revolution here? Well, in this case here, they're providing us with a y coordinate and asking us for the time here. It's not quite as straightforward. In order to do this, I actually have to go back into y equals, and I'll have to enter 15 into this. Okay, and now when I graph this, okay, it draws the 15 along here, and what I'm interested in is the x coordinate here and the x coordinate here, because here's one complete revolution, and those are the times when that occurs. So now to do that, I'll press second trace to get into the calc menu, and this time I'm looking for where these things intersect. And now I'll move the cursor close to that point of intersection. It doesn't have to be right on, it's just close. The calculator is asking me, am I on the first curve? And I'll press enter to say yep. It'll jump straight down. It'll say, am I on the second curve? Yep. Then it's going to say, is this okay as a starting point to make my guess as it makes the calculation? And it doesn't matter, it should be fine. Press enter, and we're going to get here, okay, that it's going to hit that point at 0.88 of a second. Now, sorry, not of a second, of a minute. 0.88 of a minute. Okay, let's just quit. Let's just quit out of that. 0.88 of a minute. Let's going to grab X. Press X. That's what the value that the calculator just had here. To say 0.88 of a minute doesn't really communicate much to me. So let's convert this to second. Let's multiply this by 60, because there are 60 seconds in a minute. Oh, there we go. So the first time this is going to happen, first is going to be at the 53-second mark. Okay? And that rounds really, really nicely just to 53. Now, let's go back to the graph. And we're going to go find that other one. So we're going to move that cursor. Again, it just has to be close to that new point of intersection. Coming around there, doesn't have to be right on, just close. First curve, yep. Second curve, yep. And that is okay as a guess, I don't care. And now we get 8.1166 blah 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 minutes. But that doesn't really communicate this nicely for me. So I'm gonna grab that number again. Now I know that the 8 here represents 8 complete minutes. So the 8 is okay, that's not the problem. The problem is this fraction here. I don't know really how many seconds that refers to. So I'm going to multiply that fractional part by 60. And look at that. That is going to round really, really nicely to 7. So what this means here is the first time it happens is at 53 seconds. The second time is at 8 minutes, 7 seconds. And those are the 2 times that we're looking for. Then the question is, how long to the nearest tenth of a minute is a person in one revolution when he is at least 15 meters above the ground? Okay, so and now it says here to the nearest tenth of a minute. So what we're going to do here, I'm going to show you how to do this. This case right here, we do want the decimals to occur. So what we're going to do here is I'm going to go in, whoops, I'm sorry, I want to go back to my graph. I'm going to go in, find that point of intersection again. Yeah, first curve, second curve, and it gives me this value right here. I'm going to just quit, press X to yank that up. Now, just for the time being, because I want that number to stay usable, I'm going to store that, and I'm going to store that in A. So I'm going to press alpha math to store that in the A variable. Good. So now that is in a different variable. The problem with X, keeping it in X, is X always changes. In fact, when I go back into my graph and then look for that intersection point, I'm going to look for this intersection point over here. Okay, move that cursor close. Now enter, enter, and then enter past the guess here. This is now what X is. X is now this 0.88. So now I will take A, alpha A, and I'm going to subtract X from it. And that's how long, okay, to the nearest tenth would be 7.2. So 7.2 minutes is how long you would be above, or at least 15 meters above the ground in one revolution here. Now the last question asks, what's the equation of the median? And that's very, very simple because we had the equation and we know that the d value is synonymous with the median, so we can just write there that y is equal to 46, and that's what we're looking for in this equation, in this question.
Given the following information, find each of the following.
All right, for this final question, really the only difference between this one and the ones that we've been doing the last couple times here is that the data is not given to us as a table, it's given to us as just a series of points. But again, we're going to separate the x-coordinates from the y-coordinates, put the x-coordinates in list 1 and the y-coordinates in list 2. So to come up with the equation here, to do the regression equation, this is the first thing we're being asked for, we will press stat, and then enter on edit to get into our lists. I've already cleaned up my lists here, so here we go. We're going to press, so we're going to enter in our x-coordinates, so 0, 4, 6, 8, 12, and 16. And now we'll fill in the corresponding y-coordinates, so 2, 10, 15.66, oops, did it again, 18, 10, and 2. So now the data is all in, and now we want to come up with answers to the following pieces here. So first thing we'll do here is we're going to quit. And now to come up with the equation, the regression equation, I will press stat. We will go over to the calculation menu, and then we're going to go down looking for that sinusoidal regression, and there it is. Everything is already as I want it. Whoops, sorry about that. And so here we go. This is the form of the equation, and we know A, B, C, and D. Now, it doesn't really tell us what to round it to, but the last couple questions have wanted us to go to the nearest hundredth, so that's what we'll do. So my equation here, okay, is going to be y equals 8.02 sine of 0.39x minus 1.58. Now I'm running out of room there, but plus 10.03. So there's my equation. What's my amplitude? Well, my amplitude right there, amplitude is equal to 8.02. It's that leading coefficient. What's the period? Well, period, and we've already done this before, is going to be 2 pi over b. Okay, well there's my b value right there. So 2 pi divided by, now I can get b, whoops, sorry, you can't see that. 2 pi, I can get b by pressing vars. To get into that stats, to get into this menu right here, we'll go to stats, over to EQ, and we're going to grab b. So 2 pi over b, and to the nearest hundredth, my answer is going to be 15.91. So my period is 15.91. Now finally the range. Now remember, your range, think of it like this, is going to be the min is less than or equal to y out to the max. The min is going to be the d value minus the a value, and the max will be the d value plus the a value. And again, we can go to our calculator and generate those values here by pressing vars, statistics, EQ, go down to d, minus vars, statistics, EQ. The more comfortable you get, the faster this is going to get. And to the nearest hundredth, that's going to be 2.01. Okay, and now I will do the same thing, but I'm not going to go through and pull that all up again. I'm just going to go with second enter to pull out that previous expression, change the negative sign, or sorry, the subtraction to an addition, and I get 18.05. And so there we go. There's my range. 2.01 is less than or equal to y is less than or equal to 18.05. That's what we're looking for.